Today we're going to graph solutions to inequalities on a number line. Okay. Basically we're going to have a few different looks here. There's more than this, but this will kind of summarize the basics. So I'm going to make 4 number lines. I'm going to scale them all the same way here. I'm going to go from -2 to 2. Okay, we could have something like x is greater than or equal to 2. Okay, greater than or equal to, we put a dot on 2, and all the numbers that are greater than or equal to 2 are to the right of 2, so we'll just do an arrow to the right of 2. And there's all the values that are greater than or equal to 2, and all the values that solve this inequality. Likewise, we could also do x is less than or equal to 2. So we do a little dot on 2, an arrow to the left, and there are all the values that solve this inequality. So all these values over here, and it goes on to infinity or negative infinity, will solve that inequality. Okay, let's change it up a little bit. X is greater than -2. Okay, that's a little bit different, and hopefully you can see the difference. All the values that are greater than -2, we start at -2 and we go to the right, but you can see that I'm using an open dot here because -2 is excluded from these solutions. -2 is not greater than -2, so we use an open dot to show that it is not one of the solutions to that inequality. And lastly, we'll do x is less than -2. Again, it's an open dot, but this time we do an arrow to the left to show values less than -2. -2 is not included. It is excluded from the solution set. So we use an open dot to show that, as opposed to a closed dot where 2 is less than or equal to 2. All right, Alicia has a number in mind. If she adds 3 to her number, the result is less than 5. Use this information to write and solve an inequality about Alicia's number. Then graph the solution set. Okay, Alicia has a number in mind. If she adds 3 to her number, she's got a number, she's going to add 3 to it. The result is less than 5. Less than 5. So there's our inequality. Alicia's number plus 3 is less than 5. So Alicia's number then, if we subtract 3 from both sides of this inequality, must be less than 2. That would be the solution. Any number less than 2 would fit this criteria that they gave us up here. So her number must be less than 2. We don't know what it is yet, but at least we've narrowed it down. And then we're going to graph this, and we just did something very similar on the previous page. There's 2, there's 4, there's 0. It really doesn't matter how you scale your number line. You can scale by 1s, 5s. It doesn't really matter, but this shows that we're dealing with a number line. We're showing that 2 is the start, but 2 is not included in our solution set. All values less than 2 do meet the criteria of numbers that Alicia might be thinking of. All right, so let's do some more here. We're going to solve these inequalities. We're going to graph their solutions on number lines. So with 4x is greater than -12, all we have to do is divide both sides by 4. You can also solve it by inspection because you know that 4 times -3 is -12. So 4's got to be greater than -3. And we'll graph that. There's all the values that are greater than -3. Again, we're not including -3 because if we plug -3 in here, we'll get -12 is greater than -12, and that's not a true statement. However, if we plug -2 in, we'll get 4 times -2 is -8. -8 is greater than -12. And if we plug -4 in, that should not work. We'd get -16. -16 is not greater than -12. It's less than. Okay, let's move on to C here. I'm going to subtract 1 from both sides of this inequality. I'll get 6x is greater than or equal to -6. And I'll divide both sides by 6. And I'll get x is greater than -1. I'm going to graph that. Here's my number line. Close dot and an arrow to the right. So we're showing that all values greater than, to the right of -1, greater than -1, including -1, close dot, should solve this inequality. So a number like 0, 6 times 0 is 0, and 0 plus 1 is 1. Is 1 greater than or equal to negative 5? Absolutely it is. But negative 2 will not work. 6 times negative 2 is negative 12. And negative 12 plus 1 is negative 11. But negative 11 is not greater than negative 5. Negative 1 does work. We get negative 6 plus 1 is negative 5. Is negative 5 greater than or equal to negative 5? Yes, it's equal to it. Let's do another one. Let's add 5 to both sides of this inequality. We'll get 2x is less than or equal to 8. And then divide both sides by 2. X is less than or equal to 4. That's the solution. And then we'll graph it. Closed out at 4. Values to the left because we're talking about values less than 4. And the last one, let's add 8 to both sides. Pause right there. If we add 8 to both sides, we'll get 15 is less than or equal to x. That's the same thing as saying x is greater than or equal to 15. Hopefully you see how that works when you flip everything around. You have to flip the inequality as well. And then we'll graph it. See, I scaled it by 5. It really doesn't matter how you scale your number line. 15 in all values greater than 15. Like 20 should work. 20 minus 8 is 12. 7 is less than or equal to 12. 10 shouldn't work. 10 minus 8 is 2. 7 is not less than or equal to 2. Jan is participating in a 6-mile run-walk for charity. If she completes the course and runs at least half the distance, then what inequality shows how far she might walk? And we're going to also graph the inequality. Okay, a little bit of trick to this one, so pay attention. She walked up to half the course. Okay, we know she ran at least half the course. She might have ran more than half the course, but at any rate, right, we know that she could have walked 3 miles. She also could have walked less than 3 miles. Okay, so if she ran at least 3 miles, she might have ran 4 miles, which would mean, she walked 2, and 2 is less than 3, so that makes sense. She might have ran 5 miles, which means she walked 1 mile. 1 is less than 3. We know it's somewhere less than or equal to 3. Okay, now if we graph that, 3, 6, and 0, 3 miles or less, I'm going to stop right here because this graph is kind of indicating that she could have walked a negative distance. That doesn't make any sense, you guys. How can you walk a negative distance? You can walk 0 miles, you can walk 3 miles, you can walk 2 miles, but you can't walk negative 3 miles. It just doesn't make sense. Even if you walk 3 miles backwards, you still walked 3 miles. So that doesn't make any sense. We're going to make a slight adjustment to this. This graph does not go forever to the left. This graph only goes to 0 and stops at 0. So those are the numbers in between 0 and 3 that actually solve our inequality. So our inequality is actually W, the amount she walked, is between 0 and 3 miles. She could have ran the entire course, which means that she walked 0 miles. She could have ran half the course, which means she walked 3 miles. So it's somewhere between 0 and 3. So take a look at the inequality and then take a look at the graph of the inequality. See how that works. And we'll do more with inequalities over the coming days. All right, so if you did not finish the problem set 61 in class, make sure that you're finishing that tonight and come in with any questions you've got over today's material, and also be ready to work hard in class tomorrow. See you then.